Look closely at this photograph of a vintage radio broadcast studio. You can see the human coordination required to build a convincing audio world. Actors holding scripts, technicians manning turntables, the director cueing the sound effects. Everyone in the room has to act in perfect sync. Today, we are going to look at a broadcast that generates itself, passing through completely empty, dark rooms. We possess powerful models for generating text, voices, and imagery. By default, they exist in strict isolation. A language model doesn't know what a sound effect is. An image generator has no concept of an audio timeline. They are isolated calculators that cannot naturally speak to one another. To bridge that gap, developers build highly specific, automated pipelines. We are going to examine a local setup engineered to do one specific job. It pulls a real science headline, synthesizes a complete audio drama, and builds the 3D room.
The breakthrough lies in the architectural engineering required to force an array of completely isolated models to pass a coherent signal down the line. The process starts with a local language model acting as a writer. It receives today's news headline, a target word count, and a genre. It outputs spoken dialogue and a structured list of character roles. That text is immediately handed off to a director node. The director assigns a specific digital voice to every character and plots out every sound effect and music cue. It completes this casting and orchestration entirely blind, without ever hearing the actors or the music it is selecting. If we look at this flowchart mapping the data, you can see how the director splits the script into 3 separate parallel processing paths. One path heads to a character voice engine, one goes to a narrator engine, and the final path routes to an ambient sound effect generator. As the data flows downward, there are no feedback loops. The character engine generating the dialogue does not know a thunderclap is being rendered by a separate machine on a separate bus. They operate completely blind to one another. The result of this stage is thousands of disconnected audio clips. It is a scattered pool of sound with no pacing, no silences, and no structural form. To turn that noise into a story, the data arrives at a central junction called the scene sequencer. As we can see in this timeline visualization, the sequencer calculates an absolute timestamp in seconds for every single audio file. It calculates the breath between lines, the exact moment the sound effect should hit, and locks every piece of audio into a strict horizontal multitrack. The timeline is then exported into a master JSON manifest. This creates a dense, highly structured text file that indexes exactly what sound plays and exactly when. This text file acts as the ultimate ground truth for the entire system. Because every line of dialogue and every sound effect now has an absolute home in time, any physical 3D world we build later must be mathematically derived from this specific map. There is a natural friction between an audio timeline and a spatial environment. To cross that gap, human developers write simple glue code that parses the physical environments listed in the text file and translates them into flat two-dimensional panoramic images. Those flat images are fed directly into Tencent's newly released HY World Mirror 2.0. This is a unified computer vision model designed to deduce physical geometry from two-dimensional pixels. The model consumes the flat panorama, wraps it into a sphere, and expands those pixels outward into a dense cloud of three-dimensional data points. In a single computational step, the model calculates the depth of objects in the room, predicts exactly where a virtual camera should be positioned, and outputs a navigable Gaussian splat, a high-resolution 3D digital asset made of millions of colored points that you can actually walk through. The pipeline has successfully taken a sentence from the morning news, written a script, generated the cast, timed the audio, and built a physical, navigable 3D environment for that specific story to inhabit. The marketing surrounding artificial intelligence often describes a single, all-knowing brain that writes, speaks, and draws simultaneously. This complete pipeline map reveals the system's reality, a fragile assembly of 10 discrete operation nodes, human-written bridge code, and one shipped 3D model. Spatially, 3 blank spaces mark unreleased models. Open-source stand-ins maintain data flow, prioritizing structural honesty. Media creation is transitioning away from the dense human performance captured in that vintage radio studio. It is shifting toward algorithmic compilation, where disparate pieces of math are stitched together by strict logic rules. The capability to turn a headline into a living space relies entirely on the sophisticated pipelines we engineer to force disparate machines to build a single world.